Okay, welcome all in this class. In the previous class, we were describing about this equation, that how the fluxes of the synchronous machines are related with the currents. So where this phi d, phi q, phi 0 are the fluxes of stator flux phi a, phi b, phi c referred on the rotor side. So this phi d, phi q, phi 0 are the stator flux referred on the rotor side, and phi f is the flux of the field winding, phi h is the flux of the damping winding on h axis, phi g and k are the flux of damping winding on the q axis. And these fluxes are related with these currents. You with the this subscript, you understand what is the id, iq, i0. These are the stator currents referred on the rotor side. ia, ib, ic referred on the rotor side. if, ih, ig, ik you already understand. if is the field current and hgk are the damping winding currents. This matrix LSS dash, LSR dash, this we derived earlier, and this is given by this matrix. This is LSS, this is RR, LRR dash, this is SR dash, this is LRS dash, and the values of various inductance and mutual inductances are given in this. So in this way we are able to write the flux equations. Now we write the voltage equations. You see, this phi a, phi b, phi c are the flux, stator fluxes, and from the fluxes the voltage is produced, because rate of change of flux is the voltage of the coil. And these are the fluxes on the rotor side. Ra, Rb, Rc are the resistances of the stator winding. A phase winding stator of A phase winding of stator, B phase winding of stator, and C phase winding of stator. So this is the resistances, and these are the rotor side resistances, resistance of the field winding, H winding, G and K winding. And one equivalent circuit of the phase winding is shown. Similarly, the other equivalent circuit will also be there. This is the voltage produced, this V. It is a terminal voltage of the stator. This voltage is equal to IR, I current flowing, IR plus N d phi over dt, that is the d psi over dt. And total flux is the psi. So it is the, you can see the under inside the stator, the winding flux produced is flux is given by phi a, or you can say the total flux is psi. So N d d psi over dt is the voltage, and IR drop is this terminal voltage. So equation for this can be written, if you see from this side, this equation can be written VA plus IARA. Here you see VA, if the current is flowing, say current is flowing, let it in the, if it is a motor, current will be flowing in this direction. So this voltage V is equal to IA into RA plus this. But since it is generator, so this will be current flowing out. We are consider current flowing outside. That's why this minus sign has been taken. And d psi over dt minus IARA is equal to be the terminal voltage. So this is the equation for case A of stator. Similarly, the equation for voltage equation for phase B winding is this, and phase C winding is this same, because psi A, psi B, psi C are the fluxes of ABC respectively. RA, RB, RC are the resistances of ABC respectively. IA, IB, IC are the currents in the ABC winding respectively. And VA, VB, VC are the voltages of ABC winding respectively. In general, this can be written as a minus d psi s by dt minus RS IS. In short, it is written, or from here if you see, psi s is nothing but this. This is the representation. Psi s is psi a, psi b, psi b in the matrix form, and this is a RA, RB, IC. So here, if you from there, psi s is the matrix, psi a, psi b, psi b. This is the diagonal matrix RA, RB, IC. So if you open this, you will get this, these three equations. So these are the voltage equation on the stator side. On the rotor side, these are the equation. The Vf is the voltage of the field winding. So this Vf, if Vf field winding is equal to IF RF plus voltage applied, because current is flowing. If you see here, if you see in this direction, current entering is considered as a, here in the field winding, current is considered as a positive. So this is IF field current. The current flowing into IH, IG, IK, and these are the short circuit current, because damping winding are short circuited. But in the field winding, current is flowing outside. Current is flowing from the the outer source. So this current will be entering into this. So Vf is equal to, if the voltage across this is Vf is equal to IF RF plus and d psi by dt, d psi f by dt. So similarly, equation 4, these are written here. Here voltage are 0. You see, these are the short circuited winding, damper winding. So voltage here is 0. Here is the voltage Vf is applied. Here no voltage applied. So these are the 0 voltages. And IH, IG, IG are the currents. And these are the stator windings. So again, see this. Yeah, these are the equations. Vf multiply minus everything, it will Vf will be positive is equal to this and this. So all these four equation can be written like this, because phi r is nothing but it is a matrix, column matrix of phi f, phi h, phi g, phi g, column matrix, and rs is the rotor side resistance matrix, and this rs is equal to rf, diagonal matrix of rf, rh, rg, rk. So if you open this, you will get these four equations. These four equations can be written in short like this, and the stator side equation can be written in short like this. Okay, and this is the part transformation. You already understand that if you want to convert ABC into DQ0, then means if you multiply this here, IE, IB, IC, or phi A, phi B, phi C is there, that can be converted into rotor side flux current or voltage. So this is part transformation. Earlier in the previous class we described, and here you see similarly means current, voltages, and fluxes, everything can be converted with the help of this part transformation. Now the psi s is the, what is psi a? It is a column matrix of phi A, phi B, phi C, like this. It is a psi a, psi B, psi C. It is this. So this, from here you see phi dq0, because what is our intention? Our intention is to convert ABC into dq0, because we will do all analysis into dq0. Why in dq0? Everything will be referred on the rotor side, and D and Q are 90 degree phase difference to each other, so there will be no mutual linkage. That's why we convert everything into the rotor side. So here you see this relation, phi dq0 is equal to P part transformation phi ABC. So from here, phi ABC means P inverse of dq0. P inverse of dq0. Let us consider for simplicity. Otherwise, you could write P inverse every time. Otherwise, in place of P inverse, you write CP. We have written another notation here. It is a CP, and transfer, either if you take the inverse of P or if you take the transfer, because it is symmetric matrix. So inverse of that and transpose of that is the same. Now the equation above, this equation you see again here. See this equation here, phi s rs vs. Remember this equation and see here. In place of psi s, here from here psi s, it is written as Cp phi psi d. Okay, Cp psi d. And in place of their rs is, in place of is, it is written as a Cp idq0, because similar to this, IABC is equal to P inverse of, or from here you see P inverse of IDQ0. Phi ABC is the P inverse of IDQ0, that is the CP IDQ0. That's why we have written like this. Similarly, here it was a VABC, so it is the CP of Is this equation clear or not? Is equation clear?
Yes.
Antram?
Yes, sir.
Okay. So this equation, because now we are trying to convert ABC into DQ frame of reference. That's why ABC is removed with the DQ. So CP, since CP is the, what is CP or what is the P? P is the function of theta. And what is theta? Theta is the angle between the rotor and stator side. So you see here again, what is this P? P was here. P. This is theta. Theta is the angle between rotor and rotating flux of the stator. So this theta, so this is the theta, and theta is the function of time, because theta changes with time, angle changes with time. So it is the function of time, and flux is also the function of flux, also changes. The fluxes of all the fluxes also changes with time. So both are the function of time. So if you differentiate this, first you take the differentiation of this, then you can take differentiation of this. So taking here my Cp as it is, differentiation of psi dq0, then phi dq0, differentiation of Cp. Okay. So here now Rs Cp I dq0, and this is written in this way. Here you see dy dt of Cp. Dy dt can be here only. Dy dt is written as a theta is what is theta dot. Theta dot is the d theta by dt. So d theta cancel, means the dy dt can be written like this. Dy dt can be written like this. Is it clear or not, Nitesh?
Yes, sir.
Okay. So here in place of d dt we have written dy dt, we have written like this only. Now since here we have to do the differentiation of Cp with respect to theta, dy dt over Cp. So we did it. As I told, what is Cp? Cp is nothing but the transpose of or inverse of P. And P आपने अभी ऊपर दिखाया आपने, पहले तो उसका इनवर्स कर लें और फिर उसका डिफरेंशिएशन करें, इनवर्स और ट्रांसपोज कर लें. देखिए इसको अगर ट्रांसपोज कर लेंगे, अगेन यू सी, इसको ट्रांसपोज कर लेंगे तो ये रो बन जाएगा. So cos theta on this side, cos theta minus 2 pi by 3, this will be one column, sine of this, and if you take the differentiation of this, it will be 0, because these are the constant. In place of cos theta, it will be sin theta. In place of sin theta, it will be cos theta. So in this way, if you do the differentiation, in place of cos theta, it will be sin theta with minus sign. In place of sin theta, it will be cos theta, and these are 0. I think it might be clear to you. Okay. And if you now see Cp, you know, Cp means the above you have seen. Cp is the transpose of P, and if you multiply, let us have another notation P1. P is different than the P1. P was the this dependent upon theta. P1 we have considered. We have taken one matrix, constant matrix, which is represented like this. एक ऐसा हमने P assume कर लिया, एक मैट्रिक्स जिसकी वैल्यू ये है. अब इसको मल्टीप्लाई करें. इफ यू मल्टीप्लाई Cp into P, Cp given above, you see Cp given above, here this transpose of this is the Cp, and if multiply it with this, this is you do yourself. क्योंकि इसमें साथ के साथ अगर ब्लैक बोर्ड पे होता तो मैं आपको करके बताता, बट इट इज वेरी सिंपल. इन दोनों को आप मल्टीप्लाई करेंगे, देन यू विल गेट दिस. इस दोनों मैट्रिक्स को सिंपली मल्टीप्लाई करिए तो आपको ये मिलेगा. तो हमने क्या करना है, इसलिए डी सीपी बाई डी थीटा जहां अबव है, ये जो आपका डी सीपी बाई डी थीटा है, डी सीपी ये था ना, डी सीपी बाई डी थीटा है, उसकी जगह हम अब क्या लिखेंगे, सीपी पी वन. So we write it as Cp P1, okay, and theta dot. So this equation above, the same equation can be written here like this, and you see Cp here, Cp here, Cp here, Cp here. So if you take multiply Cp minus here, Cp inverse here, or you can say P multiply here, so this will be identity matrix 1. This will here. Here multiply by P or Cp inverse, this will be identity matrix, so it will be theta P1 and psi this dq0. multiply here CP inverse RS CP IDQ0. This multiply here CP inverse, it will be 1 identity matrix. So this equation we will get. Again, dy dt of psi dq0, yeah, d theta by dt, and means theta, what is theta? Theta is the angle between rotor and rotating flux. उसकी स्पीड, रोटर की स्पीड, रोटर एंगल, रोटर एंगल. So differentiation of rotor angle is the speed, angular speed of the rotor. So theta dot is equal to omega. It is P1 and psi dq0. This is equal to RS again. Doing RS I dq. This equation will come. So this equation, now you see, this equation can be, if you explore this equation, these are the three equations: psi d, psi q, psi 0, psi d, psi q, psi 0. Three equations. If you open this, you will get these three equations. It is a omega and p की value आप ये रखेंगे 1 minus 1, and if you open this, you will get these three equations. I think there is no problem in this. Do yourself 1 or 2 steps. Here, open this, means in place of this, write a column matrix. In place of this, write this matrix. This is a column matrix. This is again IDQ0 column matrix. BD to BD, VQ, V0. These three equations will come. Is it clear or not?
Yes, sir.
Deepika? Yes. Deepika, is it clear? Deepika is not there?
Present, sir.
हाँ, इसे देखिए आप, ये क्लियर है तीनों इक्वेशन. Now rest 4 equation we have repeated here. Rest 4 equation ये as it is, ये आपकी चार जो ऊपर लिखी थी, ये ऑलरेडी दीज इक्वेशन. देखिए यहाँ क्या हुआ, साई ए साई बी साई सी को हमने DQ0 में कन्वर्ट कर लिया. ये ऑलरेडी DQ0 पे था, रोटर साइड में था. ये इक्वेशन हमने दोबारा से रिपीट कर दी एज इट इज. तो दीज 3 and these 7 4, 3 plus 4 7 equations are there which are written simultaneously here. These are the rotor equations. ये हमारी सारी रोटर साइड में फ्लक्स इक्वेशंस है. So these are the flux equations on the rotor side. So sorry, voltage equation. These are the voltage equation on the rotor side. ये सारी वोल्टेजेज हैं DQ0 और ये हमारी चार रोटर साइड वोल्टेजेज हैं. So these equations, voltage equations are referred on the transfer to the rotor side. In short, we have written this equation above also. Now, is there any problem in this? इसमें किसी को कुछ कहना है?
No, sir.
No, sir.
Okay. देखिए, बिफोर स्टार्टिंग स्टडी स्टेट परफॉर्मेंस, कोई नया ज्वाइन किया अभी? ये जो देखिए, ये जो आपके मार्क्स दिख रहे हैं, दीज आर फॉर द असाइनमेंट्स. जिसने जितनी असाइनमेंट पूरी की है, तो आई एम गिविंग 1 or 2 days. Within 2 days, if you submit few more assignment, they will be modified. So better to do some homework. अपने असाइनमेंट्स को आप पूरा कर लें, एक दूसरे की हेल्प ले सकते हैं. एंड फाइनली व्हेन यू submit in your own handwriting. So submit your assignment in your own handwriting so that these marks can be updated. Okay.
सर इसमें गूगल फॉर्म वाला भी
तो
मतलब इंक्लूडेड है क्या?
Pardon?
सर जो आपने गूगल फॉर्म वाला एक कहा था ना असाइनमेंट सबमिट करने के लिए, मतलब उसमें क्वेश्चन सर
असाइनमेंट आपको क्लासरूम पे सबमिट करना है.
सर जो गूगल फॉर्म वाले क्वेश्चन
क्लासरूम नहीं, गूगल फॉर्म नहीं, वो नहीं. असाइनमेंट जो मैंने आपको क्लासरूम पे दी हुई है असाइनमेंट ना, क्लासरूम, गूगल क्लासरूम पे जो असाइनमेंट दी है, वो सारी 6-7 असाइनमेंट है. सबको सॉल्व करके इसको अपलोड करना है. ओके. नाउ वी विल डू द परफॉर्मेंस. देखिए हमने अब तक क्या किया, वी हैव रिटन द फ्लक्स इक्वेशंस एंड वी हैव रिटन द वोल्टेज इक्वेशंस. फ्लक्स इक्वेशन भी लिख दी और वोल्टेज इक्वेशन भी लिख दी. अब वो इक्वेशंस को क्या करेंगे, स्टडी स्टेट परफॉर्मेंस एनालिसिस और ट्रांजिएंट एनालिसिस. स्टडी स्टेट क्या होता है, whenever some disturbance comes, and finally what will be the net change, that is the steady state performance. net change क्या होगा, सपोज करिए आपकी वोल्टेज में या लोड, इफ द लोड चेंजेस बाई 1%, अगर आपका और लोड चेंजेस बाई 5% लोड चेंज हुआ तो आपका वोल्टेज करंट इक्वेशंस पे क्या इफेक्ट पड़ेगा? फाइनली net change in the system is called the steady state performance. And if you want to find out the transient performance, then at every moment you want to know during the when the load changes, then at every moment realizing before getting the net change, before reaching to the steady state, how the different parameters behave, how they are changing with the time. That is the transient analysis. So now we will perform the steady state analysis. Here you see these are the equations. The flux equation you know. These are the flux equations we derived in the last class. Again we have written in short. You know the detail of these flux equation you know. And this detail of the flux equation again this is repeated here. ये हमने last time आपको in the last class में ये flux equation ड्राइव की थी. इसी से अभी आपकी voltage equations आई हैं. So these are the flux equations. You understand it, what is the meaning of this? What is the meaning of these flux equations? And this already you understand CP. CP is the transpose of or inverse of the path transformation P. Okay. So from here we write phi d, phi f like this. You see here. From here, we write the equation for phi d, phi q, phi 0, phi f, all the 3 and 4, 7 equations. So here we are trying to write phi d, phi f, means all the equation on d axis. D, phi d is on the d axis, f is also on d axis. And h is also on d axis. H, damper winding, there are 3 damper winding, one winding on the d axis and g and k are on the q axis. So writing the d axis on one with each other and q axis, यहाँ से हमने ये सभी इक्वेशंस को यहाँ पे लिखा है. तो writing these we have written these 6 equations from above. जो हमारी मैट्रिक्स थी उसी से ये लिख दिया है. देखिए यहाँ पे others, because phi d depends upon id, if and ih. Phi d is not depending upon iq, ig. You can see from here, because this phi d, because these are 0, here it is 0, here it is 0, so they will be 0, and here this is 0, so they will be 0. So only 3 terms, only 1, 2, 3 terms will be there in phi d. Similarly in others also the 3 terms will be. हर एक में आप देखिए एक रो में 3 ही टर्म एक्टिव है, अदरवाइज ऑल आर 0, तो 3 ही टर्म इसमें आएंगी. So we can write all these equations. Now when we perform the steady state analysis, there are 2 types of study. One is the no load analysis, no load, and another is the full load. No load means under steady state when there is no load. Load is not connected. हमारा synchronous machine है, जनरेटर है, उस पर लोड कनेक्टेड नहीं है, केवल इनपुट दे रहे हैं और ये वोल्टेज जनरेट कर रहा है. मिनिमम इनपुट दे रहे हैं जिससे वोल्टेज जनरेट कर रहा है, और आउटपुट में इलेक्ट्रिकल साइड में कोई लोड कनेक्ट नहीं किया है. एक तो ये हो गया. दूसरा, इलेक्ट्रिकल साइड में हमने फुल लोड कनेक्ट किया है, तो 2 डिफरेंट एनालिसिस हो गई. सो फर्स्ट ऑफ ऑल वी कंसीडर दैट द load is not connected. Now under steady state analysis, as we know that steady state का मतलब क्या है? No oscillations, no disturbance. Steady state means finally what will happen? Finally तो डैम्पिंग वाइंडिंग में करंट नहीं फ्लो होगा. फाइनल डैम्पिंग वाइंडिंग कब एक्ट हो रहा है? Whenever there is a relative motion between the rotor and rotating flux. Steady state में क्या है? फाइनल स्टेबलाइज हो गया. There is no relative motion. So IH, IG, IK will be 0 in steady state. Steady state में IH, IG, IK will be 0. IH means this will be 0, and IG and IK are 0. तो ये पोर्शन देखिए IG and IK, they will be 0. Under steady state, all these will be 0, and all this will be 0. ये ट्रांजिएंट एनालिसिस में 0 नहीं होंगे, अभी ये और 0 हो जाएंगे. साथ में ही सिंस इट इज अनलोडेड मीन लोड इज नॉट कनेक्टेड. लोड कनेक्ट नहीं है मतलब स्टेटर पे कोई लोड नहीं लगा है, तो आई आई आईसी भी 0. लोड कनेक्ट नहीं है तो आई मीन हर एक फेस में करंट 0, तो आईडी आईक्यू आई 0 विल आल्सो बी 0, क्योंकि आईडी आईक्यू आई 0 भी तो यहीं से आए हैं, आईएबीसी से, तो दिस इज आल्सो 0. सो आफ्टर पुटिंग आईजी के 0 और दिस 0 and ID 0, ID IQ 0, if you put this, but जब ये भी 0 पर कौन सा करंट बचा? केवल ये बचा, फील्ड करंट। फील्ड करंट, क्योंकि फील्ड करंट से तो वोल्टेज प्रोड्यूस होगा, और फील्ड करंट नहीं होगा तो वोल्टेज कहाँ से आएगा? तो फील्ड करंट ओनली IF इज देयर, और फील्ड करंट कितना होगा? VF बाई RF। जितना हमने वोल्टेज लगाया है फील्ड वाइंडिंग में, डिवाइड बाई RF इज द फील्ड करंट। तो ये फील्ड करंट ये है, ओनली दिस करंट इज देयर। फ्रॉम हियर वी कैन फाइंड दिस, वी कैन राइट this MDF, it is IF. So all current except the field current are 0, and in place of field current we write VF by RF. So this B equation will be changed like this. जो हमारी 6 इक्वेशन ऊपर थी फ्लक्स की, वो अंडर स्टेडी स्टेट एंड अंडर लो लोड कंडीशन फ्लक्स की इक्वेशन ऐसे कन्वर्ट हो गई। और वोल्टेज की इक्वेशन, नाउ करंट की इक्वेशन है, अब वोल्टेज की इक्वेशन एक बार आप देख लें। देखिए ये जो वोल्टेज की इक्वेशंस है, जो हमारी ये याद रखिए, ये जो वोल्टेज इक्वेशंस हैं, VT VQ 0 एंड VF दिस 1 2 3 4 5 6 7, दीज आर द वोल्टेज इक्वेशन। इसमें भी हम वही कंडीशन रखेंगे क्या? IH IG IK are 0 and ID IQ is also 0, only IF is not there। IF is there, IF की जगह VF by RF। तो जहां IF है, ये IF है, वहां VF by रखे, एंड दे if you do it, the equation, the voltage equation will be converted. This VT0 will be this equation, VT0 plus W, and this equation will be there, and VQ0 will be this equation. And in place of here phi t0, यहाँ से इसकी phi की वैल्यू, और यू कैन से psi की वैल्यू यहाँ से फिर यहाँ रख दिया, तो ये आ गया। मतलब VT0 VQ0 both equation can be written here। तो these are the equations। dx रोटर साइड में, d एक्सिस वोल्टेज स्टडी स्टेट में, रोटर साइड में, रिफर्ड ऑन रोटर साइड स्टडी स्टेट में VD एंड VQ रिफर्ड ऑन रोटर साइड की ये इक्वेशन हो गई। मतलब इफ बिकॉज स्पीड इज नोन, सिंक्रोनस स्पीड इज नोन, एंड फील्ड वोल्टेज हम कितना अप्लाई कर रहे हैं वो हमें पता है,